Hello, and welcome back to Dagish America Presents. I'm Ben Harrell, and as always, I'm so happy to have the opportunity to talk to you about the industry that I work in. On the last episode, we talked to Aubrey Moore about staying safe on fumigations. It's so important to keep everyone on the fumigation site and the surrounding areas safe at all times. Today, we're going to dive into the application day. This is one of the busiest times of a fumigation, which means it's also a day when things can sometimes go wrong, especially if you're unorganized and unprepared. To help us out with today's topic, we've invited Pete Mueller from Fumigation Service and Supply to join us on the podcast to help explore the best possible ways to ensure a safe and effective application. So, please help me welcome Pete to the podcast. Pete, how you doing today, buddy?
I'm doing excellent.
That's good. So I know this is your first time being on the podcast, so I always like to give first-timers an opportunity to kind of tell us a little bit about themselves.
For sure. Yeah, first and foremost, thank you for the opportunity to be on. I think you've done a great job with what you're doing and driving here, and our company as well is a firm believer in sharing through education. And it's a lot easier to educate people than to regulate people. So thank you. And
I like that.
Congratulations for setting an example for the industry.
Oh, thanks. I appreciate that.
As Ben said, my name is Pete Mueller, and I'm president and owner of Fumigation Service and Supply. I grew up in Westfield, Indiana, a little bit north of Indianapolis. I think I had kind of a rarer upbringing than most. That growing up, all my heroes were fumigators. Fumigation Service and Supply is a family company, and I'd like to think that it's continued that way, even though our extended family is significantly larger. After high school, I did 2 years at a small school in rural Illinois, got an associate's degree, and then transferred to Purdue University, where I finished my Bachelor's of Science in the School of Agriculture, focusing on grain industry and insects. So it's always been near and dear, and I was lucky to have an opportunity to dive in a little bit when I was younger and less busy. When I was at Purdue, I worked with Dr. Dirk Meyer and Dr. Klein Liligy on the implementation of sulfuryl fluoride in flour mills, so what's now Profume, and how to map it and how to measure it during a fumigation. It was a nice jumping off point. When I graduated, I went to work with Fumigation Service and Supply and opened an office in central Illinois, Bloomington area. Ran the office and grew the business there until I moved back to north of Indianapolis, where our corporate office is, about 4 years ago.
Yeah, so I know you guys do a lot more than just fumigation, but most of your career has been mostly focused on fumigation, correct?
Yeah, I think the name Fumigation Service and Supply kind of eliminates some opportunities sometimes because, so there should be commas in there: fumigation, service, and supply. So the fumigation side's kind of self-explanatory. We reach an economic threshold in the fumigation's best practices. That's what we do. The service side is integrated pest management, inspections for food facilities, processing, baking, milling, large warehouses, seed industry, and so forth. And then lastly, supply. We also supply products to people that are trained and equipped to do it themselves.
Yeah, I mean, I had a pretty good feeling that you guys had a hand in all of that. So even though the commas aren't in the name, I kind of already knew that the commas were there.
I think fumigation sometimes is the F word in pest management, but it is definitely a valuable tool, and I think we'll probably get into that a little bit deeper as we go along.
So this episode, I kind of wanted to talk a little bit about the application day, kind of what transpires during the day that you've shown up. So you've already done the walkthrough, you've already won the bid, you've already ordered all of the fumigant that you need, you have all the equipment lined up, you're showing up day of with a crew, and you're ready to actually start the application. That's kind of what I wanted to talk about today. And I know one of the first things that you have to do when you arrive, besides going through and doing one final inspection, is actually taping and sealing the facility and making it structurally sound enough to hold the fumigant during the exposure period. So I was kind of just hoping that you would walk us through that tape and seal process and kind of what it entails.
Yeah, tape and seal is probably the most fun part of the fumigation because, last re-registration of phosphine, it included the verbiage that, it is required to seal. Things like powered vents and fans, windows need to be closed. We need to have some way to retain the fumigant. So to have a successful fumigation, you need three things: is time, temperature, and concentration. And sealing a structure for fumigation doesn't really have a lot of rules per se. There's tape and seal with plastic, adhesive, tape, a paper tape, like the name suggests. There's even tarps that are used in sand snake or water snake to the ground, impervious surface to do a fumigation. I often hear it compared to as if you were going to seal the building up to try to keep water in, like it was a bucket. Any place where the water would leak out, we would want to figure out how to restrict or reduce the leakage or loss that would happen. There's two types of sealing that we do, obviously for bystander safety. We don't want gas leaking out or into an area where people not involved with the treatment, or people involved with the treatment for that matter, would incidentally be exposed to the process. But then we also have the efficacy side of it. So we talked about the bucket of water analogy. I also like to think if you take like a colander and push it down into that bucket of water, where is the water going to squirt or come rushing in? Because from the safety standpoint, we don't want to lose it, have an exposure, but we also don't want a chimney effect in the structure to pull fresh air in and dilute target areas that we want included in that treatment.
Right. And it's some of these facilities that we fumigate, it can get pretty tricky trying to figure out all of the areas that need to be sealed. I mean, there's overhead doors, man doors, things like that are pretty obvious, but man, there's some tricky roof vents that you have to seal when you're talking about, like processing facilities, mill facilities. If you're talking about grain bins, you have sometimes the tunnels underneath the grain bins have to be sealed up. All of the travel path for the commodities have to be sealed up because you don't want gas leaking out into areas that you're not intending to fumigate, like maybe the bin next door to the bin that you're fumigating. So there's all these things that you have to think about when you're doing your initial inspection to include in that tape and seal, because it's going to have an effect on your labor costs as well.
Absolutely. And, we're talking day of, but there's some things that we have to put in place before we get to that situation. I don't think there's a finish line with our safety program. Our safety program is the best that we know it is today, but tomorrow we want to improve on it. And some of the things that commercial fumigators, not just ourselves, need to contend with is, elevated working surfaces, slips, trips, and falls. There's a lot of ladders. Sometimes ladders are too short, so we have to have powered work equipment, powered scissor lifts and boom lifts. We've had to have a crane come in before. Obviously, respiratory protection, not only for the gas, but getting into high dust environments. Confined space, you might need to go inside of a dust collector or a dryer type situation to plug or block off an avenue for gas leakage. So lockout, tag out. And then we found that just to create awareness, having the basic entry level of OSHA 10 or OSHA 30 kind of opens up the eyes to the team that's out there.
Yeah, those are all absolutely critical points. And those are all things that you need to be considering when you're doing your initial inspection and walkthrough. And then the day of, myself, I always, I do my initial inspection and walkthrough during the bidding process, but then I'll do another walkthrough because typically a lot of times that initial inspection walkthrough, you may do it, a few weeks up to several weeks in advance, and things can change sometimes. So it's always a good idea to walk through it. And heck, you might have missed something on your initial walkthrough. or the structure has changed in some respect where you have to seal things up in a different capacity now. So yeah, having that checklist in place so you can hit the areas that you know you need to hit. So it also helps with having to know what kind of equipment you have to have on hand too, because those are all expenses. You know, how many lifts you need if you need them, how many ladders you need, the height or the size of the ladder that you need, how much materials that you need, you know, as far as poly and tape and spray adhesive, where you can and cannot use spray adhesive. All of that stuff is done in the initial walkthrough, but it gives you a good idea on what you need to have on hand on that day. And then also the labor involved. How many people are you going to need to have on hand to actually accomplish the task in the given amount of time? That's important as well. And all of that goes into that initial inspection and then the bidding process. So all of that is done before you show up on the day of. But just because it's been done doesn't mean that you can't expect surprises the day of also. Things will change and you sometimes have to change with them in order to have a successful fumigation.
No, there's no completion date on every treatment. There's no completion date on the safety portion of it. It's constant refinement. The day of, we have what's called a tailgate talk. It's literally on the tailgate or the hood of the vehicle. We go and talk about everything, like you said, from variables like weather or production schedule. Sometimes there's trains running on the site. Sometimes there's other contractors that are completely oblivious to what we're doing, that we need to communicate some of the hidden risks with or eliminate the risks so they don't come walking into a facility or try to cut box off and start up equipment that they're working on that might pull grain or pull air into a space that's not involved in the treatment.
I'd love to say that doesn't happen, but I think any experienced fumigator with a few years under their belt have had things like that happen where people have cut locks off so they can move grain or entered an area regardless of how many placards you put onto it. So you have to be aware of that and you have to try to make the area as least accessible as you possibly can, because there are people out there that are going to try to do it. And it's really tough to police that.
Absolutely. Absolutely. The general public doesn't really have a concept of what we're doing. You know, the movie Breaking Bad has kind of ruined it for us, where they were, you know, inside the houses that were being fumigated. I mean, a fumigant is a pesticide that reaches the target organism in a gaseous state. So they're inhaling it. And, you know, the thought of a bug bomb or the thought of, you know, exposure dermally doesn't really apply to what we're talking about. And we can never lose focus that we're on site to modify an atmosphere and create an environment that's conducive to targeting hidden pests in the product, the structure, the equipment. And it's a nice chance to refocus when you get on site, to do the tailgate talk. You know, some of these people that we work with are related. We get really close to each other with, like it or not, with the travel and the jobs, you know, day in, day out, every weekend together. It becomes like a family. But when we get on site, you know, to draw the focus, to communicate the risk, to put the plan together, because even though we've fumigated it 2 times a year for the past 20 years, every single treatment we approach as if it's a unique and individual experience, because there's so many variables that go into being safe and successful. It requires that focus when you get on site to be prepared.
Yeah, and you're right. Those variables can change, and a lot of times those variables are completely beyond our control. You know, like weather, atmospheric conditions. I mean, we can't control the weather yet. I mean, we can control the weather or the temperature of the fumigated space in some capacities, but if a storm comes in, we have no control over that. And a storm is going to have a major effect on how well that gas holds, regardless of how well you seal it. So you have to be prepared for that to some extent. But, you know, we're talking about safety, and going kind of hand in hand with safety is monitoring. So we have to do monitoring for these jobs as well, both for efficacy to make sure that we're actually killing the target pests that we're intending to kill, but also for safety to make sure that everybody that's working in the environment stays safe. And in order to monitor for efficacy, I know that we have to oftentimes run monitoring lines inside of a structure. And I mean, for that matter, when you're using cylinderized fumigants, you have to run introduction lines into the facility as well. So I wanted to kind of pick your brain a little bit and have you kind of introduce us to the monitoring line application and the introduction line application. I mean, how do you know where to put the introduction lines, and then how do you know where to put the monitoring lines?
Yeah, so we've got two types of treatment that I kind of want to drill in on. Is we've got a space or structural fumigation, and then we have a static grain mass or static commodity. And we approach them very differently on the gas introduction point. We'll start with the space fumigation first, as you want to get the lines evenly spread out if it's a wide open warehouse that's not segmented off, relatively new construction. We do an evaluation on half loss, which is how much time we think that it'll take the amount that we applied to go from 100% to 50%. So we give that a time rating. Sometimes we find that it's 48 hours. Sometimes, if, like you said, if a storm goes through or it's old construction, it's significantly less. So we would evenly spread those out towards the center. Sometimes these jobs, I just got off of one that was about 18 million cubic foot warehouse that was wide open. To introduce the amount of gas from the outside through a line in, it takes multiple lines just to get the amount in. So we talked about the time, temperature, and concentration. We can't start our count. We can't start accumulating the time for control until we hit equilibrium. So the faster we can safely get the gas into the building, the quicker we can start looking at the accumulation side on time. I also, on structures, like to look at areas that are more prone to leakage. So if we're doing, a facility that has processing, it has a lot of ventilation and aeration on it, dust collection, connected to warehouses or bagging areas. I like to segment off those higher risk areas, knowing that our half loss time will be significantly shorter than the rest of the warehouse.
That's a great idea, by the way.
You find out the hard way sometimes on some of these
Yeah.
new buildings, but I find that it helps, keep our cost and inputs lower and be able to pass that along to a customer. So in the warehouse, having a couple monitoring lines that are put in there helps us make sure that we keep an eye on it. But on the application lines, we might have one or two more extra points in there to apply, so that way if we need to top off or add gas, whether it's just leaky by nature or if a storm comes through and wicks some of it away, we can add at that point. So you're not adding to 100% of the structure, you're only adding to 10% of it.
Right. And that's really important, especially when you're talking about larger facilities and also multi-floor facilities. If you're doing a mill facility and you only have an introduction line on the first floor, but you're monitoring and you find out that you need to add gas on the seventh floor, well, adding it to the first floor is not going to help you very much, or it's not going to help you very quickly, at least. You will reach equilibrium throughout the entire structure if it's sealed right, but you need to make sure that, and I know you agree with this, you need to make sure that you have introduction lines on every floor or in key areas. That way, if you are taking monitoring readings, and you need to add gas, you're adding it directly into the area or as close to directly into the area where you're seeing the highest amount of loss.
Yeah. I know we're jumping back and forth from introduction to monitoring, but kind of one is hand in hand with the other.
Yeah.
And when I place monitoring lines in space fumigation, structural fumigations, I like to put myself at a disadvantage. So if there is a dock that I know and suspect is leaky, or if I know that there's, a weakness or an older area in the structure that might be more prone for air to come in with convection currents going up, towards the ceiling, that's the one that I want to base our CT. That's the one that I want to base our readings off of. Because if we put it in the middle of, the tightest area, 6 feet from the introduction line, we're going to adulterate our readings. We're going to have higher concentrations than we actually do. So when we go in, we know it's a unique event. It's a very invasive event sometimes for our customers that they have to shut down. Some of these places, production losses are hundreds of thousands of dollars per shift in production. So the emphasis on doing the best job that we can, the best job available during that event is critical. It's very important, to myself and the team as applicator.
Oh yeah, absolutely. So I know we talked about, running introduction lines, running monitoring lines. I did want to kind of dive in a little bit because I know for the most part, regardless of what fumigant you're using, most of the tape and seal and the facility prep is essentially the same. There are a few differences depending on vapor pressure, the fumigants sometimes, but for the most part, a tape and seal is a tape and seal. The introduction lines for different products are different sometimes. The monitoring lines are typically the same, but I know that there are some differences and considerations that you have to have for each individual type of fumigant that you're actually applying on the day of. So I wanted to talk a little bit about that. What do you think are some of the considerations that you have to have in mind when you're applying? And I'm going to go through the main 4 fumigants that we use here and give you an opportunity to talk about all the main 4. But when you're applying phosphine first, what are some of the considerations that you have to have?
Yeah, so phosphine is an oldie but a goodie. I think it was identified in England, or first described and used as a fumigant in 1889. So it's been around. It's acknowledged by most of the countries that care. The label in one facet or another is accepted, and we have a long history of using it. We do live in a more modern age now where there's a computer on every desk, and we have the hazardous monitoring controls and systems throughout the facility to give us feedback and data points on the different parts of the operation. One thing that is known about phosphine, or a disadvantage, is it's corrosive to soft metals and computer components. So it does take some extra preparation in the front side to section those off or remove them. It is a slower killing fumigant. It affects the ATP energy portion of the cell. So to get 100% mortality, we need 36 hours or greater at a warmer temperature. But it is very predictable. I hear a lot on the grain side that it's heavier than air, so we just throw it in the top and it'll settle to the bottom. I've not found that to be the case. I think 20 feet through clean corn is achievable for passive diffusion through a grain mass. But if we're talking about flour silos that are multiple stories tall in a mill, you'll be lucky if you get a foot or a foot and a half. So we need to think about how we help that gas migrate through static grain masses by turning on J-system blowers or pressurize it to move it through the system, or in some cases get the facility empty or drawn down on product before the treatment happens.
Yeah, I think with phosphine's rare too, that not all phosphine, there is cylinderized phosphine, but the most prevalent phosphine that's used is metal phosphides, or aluminum and magnesium phosphides. And so with aluminum and magnesium phosphide, one thing that makes it different from the cylinderized phosphines is that there's a spent material that's left behind once the chemical reaction's taken place. And oftentimes you have to clean that spent material up. Now, depending on the product that you're using, sometimes it comes in pre-packs that are permeable, so it releases the gas, and the spent material is easy to collect because it's still in those pouches. But in some cases, when you're using like loose tablets and pellets, you have to collect that back up, and then it has to go through some kind of a deactivation process before you can actually dispose of it. So that's another thing that I think that makes phosphine a little bit different than the rest of the fumigants.
Yeah, I mean, you have a great point. It is advantage to it is it's relatively low cost. It's the solid phosphine, the good old pellets and tablets are the cheapest form that are out there. Vegas has a tremendous reputation for quality product. I'm not just saying that, but they have, phostoxin is kind of the Kleenex of the aluminum phosphide brand, and magnesium lesser known. but it does give us options for space fumigations that pellets and tablets are a little bit difficult. So, to kind of drill in on what you were saying is anytime that product is cleaned or processed, we don't want to introduce dust. And there's not much, about a third of it after the reaction happens. We need atmospheric moisture and temperature to have the gas react or have the aluminum and magnesium phosphide turn into hydrogen phosphide. But if it's cleaned and processed and ready to go to the consumer, we need some way to retain that. That is with prepack formulations. They're like Tyvek or coffee filter type material, somewhere in between. They're roped off in the head spaces of bins. You even have a popcorn rope formulation that uses tablets. Kind of looks like a bunch of egg cartons put together.
Yep.
Allows us to go into popcorn. Very expensive, very unique product, and retain that dust and remove it after the treatment.
Yeah, that's one thing that really makes phosphine different. And it is the cheapest option out of all the fumigants. But you also have the extra labor considerations often when it comes to the aeration and the post aeration, because you have to collect that spent product up often. Not always, but often you have to collect that spent product up and then you have to deactivate it and dispose of it. So it's still the cheapest option, even with the labor involved most of the time, but it is another consideration that has to be taken when you're planning these jobs. And then the corrosion risk, of course, is something that you have to take into consideration with any phosphine product that you're using. Now, I did want to also ask about the other most prevalent fumigant that's on the market, and that's sulfurofluoride. I know that it has its own book of considerations that you have to think about when you're fumigating with them. So I just kind of wanted to give you an opportunity to talk about sulfurofluoride as well.
Yeah, sulfurofluoride is a nice product to use. Like we said, it's not the cheapest, but it is different chemistry than what we have with the different formulations of phosphine. So it's a nice, I don't want to say resistance breaker because we're still having controls on populations of insects with phosphine. We just need to increase our level. So joke that dead insects don't breed resistance or tolerance. We kind of owe it to ourselves and our customers to go at concentrations that will kill the target species that we're going after. But if you do suspect that there's an issue, sulfurofluoride is kind of a go-to product or the only other option to go to achieve control. And I want to clarify that there's a couple different formulae or a couple different types of sulfurofluoride. The only one that's approved for food contact surfaces, food production facilities, and commodities as it pertains to sulfurofluoride would be Profume.
Yeah.
Profume is a Douglas product manufactured out of California. The reason I say that is there's two other types. There's Vicane and Zyfor that are used for drywood termites and structural fumigations, but do not have a food or feed label.
Right.
Advantages with sulfurofluoride. So it's non-corrosive, non-flammable. That's 98% pure, and it's ready to use. We do have a bit of a disadvantage where we have cumbersome cylinders to deal with after the treatment. So you either have to get into the hazmat, hazardous materials, CDL to transport it, or pay a LTL freight driver to move these pallets of gas around. They do get bumped or removed from trailers because they can't travel with food or pharmaceuticals. So if you're going into a food facility, there's some extra preparation that need to go into or extra consideration to make sure the gas actually shows up, make sure the Profume actually shows up on site. Profume is, in my opinion, the most expensive fumigant as a company to get into. The monitors are more expensive. The additional lines take some time and are more expensive. There's annual reoccurring stewardship training that's required. It's not necessarily a negative. It's kind of a good deal, but it is expensive to bring all the people to one space because you can't do it virtually, like we're doing this podcast, they need to be in the seat and paying attention. And it's also an expensive one to scale. So if you're a company or a facility that has one or two locations that's set up to do it, and you're doing them simultaneously, you need to go through, and it's not the old Draeger pump and tube, colorimetric tube situation. It's our scientific monitors that we look at the concentration of the gas. And then the last, I think, disadvantage to sulfuryl fluoride, if there are some, is cold weather fumigations and egg mortality. I necessarily think it's a tolerance, but the mode of action for red flower beetle, once you start getting low, the concentration that you have to go to is so high to get lethality on red flower beetle. Sometimes other methods in IPM, cleaning, residual treatments with insect growth regulators, or fogging with Vapona, are more effective than full-scale structural fumigation. That's a rare situation, because most of the facilities that we're called to 75, 78 degrees or higher achieve a very high level of mortality and success.
Yeah. Another thing that is interesting about sulfuryl fluoride is just the way that you measure and set up for the fumigation. With all the other fumigants on the market, you have a very prescribed dosage that's typically measured in parts per million or maybe grams per 1,000 cubic feet. And sulfuryl fluoride is measured the same way, but they have a computer program called a Fumiguide that you can actually use to conduct the fumigation and measure the fumigation to make sure that you're having success. And it's really about the only fumigant on the market that has that. And that computer program takes a lot of the guesswork out of the equation. Now, you still have to do your walkthroughs. You still have to prep the facility properly. You still have to input the correct data into the Fumiguide in order to get the correct results. But it's really interesting. It gives you all of these variables to work with. So if you have the ability to change the temperature of the fumigated space, you may reduce the amount of gas that you need. If you increase the amount of gas that you need, you may be able to decrease the exposure time that you need. So you can kind of tweak, in a lot of cases, you can kind of tweak all of these variables and still end up with a very successful fumigation. And just the fact that you have a computer program that will track that, and then as you're entering the correct monitoring data, it will tell you how to react to the fumigation. And it's the only fumigant right now on the market that has that ability. So if a storm does come through and you take a monitoring reading and you input that new data into the computer program, it will tell you, hey, something's went wrong. You either need to extend the exposure period out by X amount of hours, or you need to add X amount of pounds of gas in order to still achieve success. And that's a rare thing to have a computer program that will actually help you make those decisions.
Yeah, that's a great example. So if you're fumigating a structure for red or confused flower beetle, to go from the temperature of 78 to 87, you can reduce your needed gas by 34%.
It's a huge amount.
Absolutely. You can, that's less that you have to bring on site. That's less that you have to vent after the treatment is over. That's less expense that the client has to endure to get this under control. All around, it's awesome to have the transparency. It's nice to have that insight into the treatment, and it's completely live. It starts at the time of quoting or doing a risk assessment on the facility for the treatment, all the way to conclusion. So you have a report at the end of it. And as you take readings in intervals, whether they're every hour or every 4 hours, once you hit equilibrium, that kind of moves the needle in the graph. And once you've achieved your CT, which is concentration over time equation, you can start aeration. So like you said, if you have a long holiday weekend, like we just did with the 4th at a lot of facilities, you can go from a 24 to 36 hour exposure based on your half loss time. You can reduce, the necessary gas for introduction by a lot. So if you get it warm, if you get it up to 87, reduce a third of the gas. If you can take it from 24 hours to 36-hour treatment and reduce it by another 10%, just by pulling some of those levers, the Fumiguide really puts the fumigator the applicator at the helm of the treatment.
Yeah, and I mean they themselves call it precision fumigation, and I would tend to agree with that. I think it really gives the fumigator the ability to make these really key adjustments to all of these different parameters to still end up with a successful fumigation with the least amount of labor, the least amount of time, the least amount of shutdown on production. I mean, again, you can change all those variables and still have the same level of success, which is nice. I also wanted to talk a little bit about methyl bromide. Now, I know methyl bromide is being phased out. We've known it's being phased out for a long time, but it's still used quite prevalently in quarantine pre-shipment and quarantine fumigations for export. So I wanted to talk a little bit about methyl bromide because I know that you've had some significant experience with methyl bromide fumigation. So I figured you'd be a great person to ask about methyl bromide and some of the considerations that we have to take when fumigating with it.
Yeah, methyl bromide is kind of a different gas. They all have their unique characteristics. And I think that's one of the great parts about our job is if you're passionate about biology and behavior of the pest, it's not too much of a jump to understand the chemistry and behavior of these fumigants. Methyl bromide is a biocide. It's not only an insecticide, but it also does kill viruses and bacteria. And that's
Right.
one of the reasons it still has usage and prevalency in our industry. Is we're not necessarily targeting the insects that are in these export containers. We're targeting things like oak wilt disease that come from emerald ash borer before it leaves the country. You can think about infesting, sub-Saharan Africa or Turkey. What I like about agriculture is it's a global currency. So you can imagine sending something from the Midwest, oak product, log product, a tractor part to sub-Saharan Africa, to Turkey, to India, introducing some kind of insect that's not native to the area or weed seeds or plant pathogen and creating some kind of famine or crop loss. Our company has a history with the Montreal Protocol and the phase out of methyl bromide. A huge amount of consumption was going to sterilizing soil for strawberries, fruits, vegetables, killing things like nematodes and weed seeds that affect those. But flour mills, grain commodities, warehousing used a lot of it. We have not found an alternative, a feasible alternative to methyl bromide for export in quarantine PPQ and ISPM 15 treatments at this time. So with my dad being very involved with the United Nations and the Montreal Protocol for the phase out, I know he's probably not happy with the amount of export treatments that we are doing still in the consumption of bromide, but there is no other option at this time. October 15th, going into the EU, sulfuryl fluoride will be approved or is in the process of being approved for log and lumber exports. And it's been great to be involved with that process as they've sought approval. Methyl bromide, when it comes to commodities, when it comes to structures, for better or for worse, it is no longer a tool that we have in our tool.
Yeah, and methyl bromide was kind of the end-all be-all of fumigants back in the day. I remember when I first became a fumigator, we were still using methyl bromide quite a bit for domestic food processing facilities, all kinds of different types of scenarios. And I mean, it just works, and it works so well. And I think that's some of the reason why we just haven't found really a viable alternative for it. I mean, we found not an apples to apples replacement for it. Phosphine can take up some of the jobs. Sulfuryl fluoride can take up some of the jobs. There are some other alternative fumigants that are being investigated right now or tested right now that can solve some of the things that methyl bromide did. But you're absolutely right. We have not found an apples to apples replacement for methyl bromide. I mean, that fumigant just worked so well on such a wide spectrum of pests that we haven't been able to find a solution, an apples to apples solution for it.
Yeah. And I think that's where the resilience of IPM comes in, where sanitation and maintenance, a lot of the complaints early on was we never had issues in the headspace of the bins or in the structure with black molds or mold spores when we fumigated with methylbromide. Well, they were present, they were just suppressed by biocide properties of methylbromide,
Yeah.
cleaning up some of the bad sanitation behaviors. So in the grand scheme of things, engineering some of those parts out, putting them on a master sanitation schedule, I think we're all healthier and better for it. But you're right. And checking the most amount of boxes methylbromide was very successful at the time that we had.
Now, the last fumigant that I want to talk about, and trust me, there are several others that are being introduced in the United States, being tested as far as formulations go, things like ethane dinitrile, hydrogen cyanide. So, I mean, propylene oxide, the list goes on and on. There's several of them we're looking at, but there's really only one other fumigant that's starting to be used very prevalently. It's been around for quite a while, but we have a new label that's on the market that allows it to be used in a much broader fashion, and that's CO2, which is primarily used for atmospheric control types of fumigation for organic products. And I think you guys have had some experience with CO2 fumigation. So I wanted to kind of pick your brain a little bit about some of the considerations we have to take into account when fumigating with CO2.
Yeah, I'm actually excited about this more than you'll ever know, because we were kind of the villain to our organic customers and non-GMO customers that wanted a solution other than chemical traditional fumigations. So CO2 is an answer to that problem. I think we still have a long way to go to really understand the behavior of it. It seems to be heavier in the structure than what we see with phosphine or sulfuryl fluoride. Phosphine is 1.17 times heavier than air. Sulfuryl fluoride is a little over 3.5 times heavier than air. Carbon dioxide is just 1.5 times heavier than air. But we find that the mode of action that we have with CO2 is different than with traditional fumigants. So we have asphyxiation, and then we have the actual toxic effect where it's a poison for the insect. Asphyxiation or noxic treatments targeting long exposures of 2 to 5% of carbon dioxide being added to the environment. If we can go from 2 to 5%, we have a biological reaction that happens in the insect where we lock the spiracle open. So the breathing portion of it that opens and closes, still the same issue. We're trying to get phosphine into, or sulfuryl fluoride, methylbromide into the insect itself to affect it at a cellular level. The mode of action with that is we're locking the spiracle open, and we actually have a desiccation or dehydration of the insect because they just can't retain water anymore. So they're open, they're breathing. There's combination fumigations that have been experimented with in the past. FSS has patents on heat CO2 and phosphine where you're going at ultra low levels. But it's great now to have it actually as the side, to have it labeled as a fumigant and an option there. Now, from a toxicology standpoint, with fumigants, using it as a fumigant, we have, if you're going from 60 to 88% by concentration, you can have a fumigation from 24 hours up to 4 days if you're 40 degrees Fahrenheit or higher. So now we are going from just allowing them to suffocate or dehydrate out to where we're coming in and actually doing more of a traditional fumigation that we're all familiar with. It is toxic. I mean, if you're at 44,000 parts per million, which isn't really that much if you think on it in the grand scheme of things, the chance of immediate death from exposure exists. So when doing a fumigation, traditional type fumigation with carbon dioxide, we're at extremely high levels where we're coming in, and we do have some displacement of the nitrogen, in the inerts that are in there other than oxygen. So it's like filling a bucket up with water, allowing those microenvironments to kind of bleed off and diffuse And we continue to add gas over time to get the exposure that we.
Yeah, and I agree with you on all of that. I'm pretty excited about CO2 myself. And I definitely think we're going to see some significant increases in CO2 fumigation over the next several years, especially because it gives us the ability to treat organic products, which none of the other products have that ability to do. But the one thing that you have to consider, in my opinion, when you're fumigating with CO2 is it tends to leak out of the structure faster and more often, and you have to have a much higher concentration or percentage inside the structure. So holding that concentration for the prescribed amount of time can be a little bit more difficult than it is with some of the other products.
Yeah, it's a multi-step process where you'll do introduction, maybe 50 or 75% of the dosage that you need. It will tend to settle. And in CO2 treatments, you tend to have some stratification of air where carbon dioxide will be lower. The lighter air atmosphere will tend to rise in the structure. So as time goes on, you sample both low and high, continue to add, and like overflowing a bucket or giving it the opportunity to bleed out of the top of the structure or the chamber will let you get those levels up to be lethal.
I know you've done more CO2 fumigations than I have. And I know with your typical fumigant products, not all the time, but occasionally you have to add gas back to the structure to maintain that target dosage. But it seems to me like with CO2, adding the gas back has to happen a lot more frequently.
Yeah. I mean, in sealed chamber fumigations or cocoon type bags that you put on, you draw down the ambient, almost like a vacuum seal on it, and then add the CO2. We'll put almost like a bubbler, like from the brewing industry at the top of it. So when we add that pressure, it somewhat inflates or increases the barometric pressure inside the chamber. It allows that lighter atmospheric air to bleed off and have kind of a check valve where you don't reintroduce air back into the structure. So you continue to add it. The line sits in a 5-gallon bucket of water. You can literally see it bubbling, air off of it. I'll take a monitor. Once we start seeing CO2 come out through that system, we'll turn off the CO2 cylinders, allow it to rest, allow more of that air to rise to the top and repeat it until we're consistent throughout the whole fumigation, the whole mass that's inside of that structure.
Sure. Yeah. Really, the only experience that I've had with CO2 fumigations are on rail cars or flower cars. And I've noticed in my experience that it takes a little bit of time to get the target dosage into the flower car, especially if it's full of flour. But then also it escapes quite rapidly too. So you end up having to add gas back a lot more frequently than you do with some of the other fumigants.
Yeah, concerns that I have for it is the insects and pests that aren't common, that don't breathe through spiracles, that have cutaneous uptakes, that are less prone to have gas that migrates. So when that spiracle opens and closes, it doesn't really breathe like our lungs do. Just the weight of carbon dioxide inside of the insect that's saturated allows the carbon dioxide to roll out of the spiracle, where fresh air will come back in with oxygen, nitrogen, argon, all the inert stuff. And that's the cellular, that's the insect respiration. Now we have things like cheese mites and maize mites, sosids that are out there that don't traditionally breathe through spiracles, but through cuticles, which just is almost like diffusion of oxygen straight through their skin. So they have kind of a filtration method that doesn't allow their body to uptake carbon dioxide. So to wait those pests out, I'm interested to see if long term, if we start selecting for those lesser known pests that we see in the environment, and start, have control of the rice weevil, the maize weevil, the lesser grain borer, the red and confused flower beetle, the Indian meal moth, and start to see some of these other insect issues popping up.
That's an excellent point, and it's definitely something that all of us, as the CO2 fumigations increase, and they will increase over the next several years, it's going to be interesting to see more of the data as it's released. And I know you guys are doing a lot of that. So I'm looking forward to seeing some of the data that's going to be released by your company and then other companies as we progress with CO2 fumigations into the future. But I definitely think that there's a bright future for CO2 fumigations, especially considering the demand for organic products is increasing significantly in the United States. I think we're going to see a higher demand for some type of treatment to be put on those products just to keep them pest free before they get to the consumer.
Yeah, I grew up in a house where can't was a word that we weren't allowed to use. And, that still kind of resonates through. So when you have a customer, potential customer, we had one a couple of weeks ago with hundreds of thousands of dollars of almonds sitting in the port that were organically certified that got stopped by customs and needed to have a treatment. And to say can't, to tell them to devalue their product by it's like 12 or 14 fold, going from organic to traditional product. It's just not a fun thing. So we're very focused on it. We're very focused on the relationship between carbon dioxide and insect activity, carbon dioxide and microbial activity, looking at judging and predicting grain quality. And carbon dioxide is a new one. It makes sense. The rest of the world has been using it in one facet or another of their programs. They don't have some of the stuff that we have, like sulfuryl fluoride. So they've had to get better with CO2, either alone or in combination. I was with some guys last week that were up working on a research project with us from Argentina. And in Argentina and Uruguay, they're actually putting dry ice inside of the silos with a little bit of phosphine and achieving mortality at just a few grams per metric ton of grain.
Yeah, so it's one of those situations where the sum is greater than the parts. So it takes less of each to achieve the same kind of efficacy.
Yeah, and that's part of the fun part about the fumigation industry is continuous improvement. There is opportunities tomorrow to improve our processes, whether it's faster, better, more predictable. Obviously, safer is always on the forefront of our minds for the end consumer and any people that are in proximity or involved with the process.
So one thing that you did mention earlier that I thought was interesting that I kind of want to drill into a little bit was you'd mentioned using J-system blowers to move fumigant through grain masses, which that process is kind of called recirculation. So I was hoping maybe you could go a little bit more in depth into the recirculation process, how it works, when you use it, and why you use it.
Yeah, recirculation on static grain masses versus space gives us the ability to manipulate the concentration inside of the structure itself. It's very hard to put readings in a large bin or silo once it's filled to know where you're at. But to be able to use the J system to pull gas from high concentration and move it to low concentration is absolutely critical to be effective. It said that through clean corn, best case scenario is maybe 20 feet of migration. There is a drawdown method where you actually, on smaller bins, can make a direct application into the moving grain stream as they pull through the reclaim conveyor in the bottom and then reintroduce the gas on top of itself. But in corn country, you're moving grain and you're also taking some fracturing and some damage with that. So recirculation allows us either to do a cylinderized application or to top dress or add probe pellets into the top of the grain mass and pull it through. So we had said the disadvantage with the phosphine is just slower in nature and more temperature dependent. So taking readings over multiple days, starting the fans up and pulling gas off the headspace or drawing it through the grain mass is a nice little tool that we have in the tool belt to make sure we're doing a good job.
Yeah. And for those of you who don't know the recirculation method, what we're doing is we're actually creating a closed loop airflow system through the grain mass when you're talking about static grain. So picture a grain bin full of corn and you're top dressing or you're putting pellets or tablets of phosphine on the top of the grain. It takes several hours, as Pete was saying, for that phosphine to go down through the grain mass and get to the bottom. So if you create this closed loop through a system of tubes and then the J system fan, if you create this closed loop where you're pulling air from the bottom and reintroducing it into the top, or in some cases going the reverse, pushing it in through the bottom and pulling it from the top, what you're doing is as that chemical reaction releases the phosphine, you're drawing through airflow, you're drawing that fumigant down into the grain mass. And so what happens is you get equilibrium inside that bin much, much faster than you would if you just let it happen naturally.
That is absolutely correct. I think all of our larger, pretty much all of them, I mean, the bins just keep getting larger and larger and larger. The structures, the flat storage, the ground piles are almost limitless. So when you don't have the option to move the grain, it is the only way you can be successful with manipulating. The other advantage with it is if you have high moisture corn, if you have wheat that has gone out of spec in the fall and you're having condensation, solid phosphine might not be the best option in that situation. So to be able to blend either phosphine in a cylinderized form with air, or to do the introduction of like a 2% phosphine blend with carbon dioxide, it allows you to pull that gas through. It goes in at about 17,000 parts per million-ish. And then the recirculation allows you to diffuse that down to a target, typically between 550 and 800 parts per million. Gives us a nice egg mortality in most situations.
Yeah, and that's an excellent point too, because really the recirculation method, in my opinion, isn't fumigant specific. It's actually facility specific, meaning that really, regardless of what fumigant you're using, if you're doing a grain bin, especially with a more dense product, recirculating any fumigant is going to help you achieve much faster efficacy, much faster equilibrium, and much faster results. So really the type of fumigant doesn't matter as much as the facility type.
Without being able to move that, that airstream or move that air mass through the product, through the structure, you're really flying blind.
Yeah, I agree. And one other benefit to it also is when you're aerating, you can actually break that closed loop and you can actually use the J system fans to pull the gas out. Now, oftentimes when you're fumigating grain bins and stuff, they'll turn on all of their own drying systems. But if that's not an option, you can actually break that loop and you can use the J system fan to pull the fumigant out and actually direct it in the direction or flow that you want it to go for bystander safety, whatnot. And it can actually help speed up the aeration process quite a lot too.
We just did it this past 4th of July holiday. We had a bin that was an in-house concrete bin that was not built with aeration on it. It had gone infested, obviously, because they couldn't control the quality, but we had manipulated the reclaim spout in the bottom to allow us to tie a J system into it, and then recirculated it drew the gas down through the grain mass, through the bottom. And when the fumigation was over, we were able to stick the tube outside of the building. And the tube that we use is like a black corrugated tile. It's not, it doesn't have slots in it like you would use for drain tile. It comes in 4-inch or 3-inch. And the fan moves at, between 3 and 600 CFM. It is dependent on the back pressure from the quality of the grain and the grain mass. But if we're taking readings, we can start to understand when that gas starts to loop through. So in that situation, we disconnected it from the top of the bin. We ran the hose to the outside of the head house of the elevator. We started the blower up. We continued to monitor for bystander safety. And after about 10 or 12 hours, we were able to draw the air through that interstitial bin and bleed it out when it didn't have engineered aeration into it already.
Yeah, it's a perfect example of what I was talking about. I'm glad you brought it up. So I only have one last question for you before I'll let you get back to your busy day. And I ask this to everybody that joins me on the podcast. What advice would you give a new fumigator, somebody who's maybe just got their license or somebody who's just walked on the job, first week on the job, whatever the case is? But what advice would you give that person about applying fumigants?
First is persevere. I mean, it is a tough adjustment. A lot of these facilities we get is, nights and weekends and holidays, but this can be an extremely rewarding profession, lifestyle for people. It's helped, well, for me, it's helped three generations, better future generations in our family. It is different every day. We talked about even the structures and the treatments, how we approach them vary every time. But you find comfort in this knowledge base that you build on itself. So it's easy to get frustrated. It's easy to have bad days and think that this is not for you. But, long term, it is a skill. It's a science that you can build on. Read and understand the label. The label was the law for fumigants. So anybody that's getting involved in it can find comfort that the manufacturers and the EPA have spent a lot of time creating guidelines, both for safety and for quality, that kind of creates a roadmap for what we do. But the fun part, the rewarding part, is you get to interpret what the best way to do some of that is: the sealing, the customer relationships, the production schedule, having staff later on that work with you and getting close with them and knowing that, you're providing a service or employment that later will help them better their life. Read. There's a lot of history with it. We talked about phosphine going back to late 1800s. There is a lot of opportunity to fill in the blanks in our knowledge just by finding out what someone has done before. And if you can't, Ben, you and your team from a technical standpoint, as well as a lot of our other suppliers and manufacturers, have never once forgot to return a call. So there are people out there that want to help you. There are even competitors. I mean, we are closely linked together, and what affects one affects all of us. So to have you be trained and equipped to be successful helps companies, whether you're attached to them or not. Treat each job like it's a brand new one. Approach it with safety focus in mind, and try to enjoy it. I mean, you get to see facilities that no one else gets to see, unless they work there. It's amazing to go from, candy factories in the city to on top of grain bins in the middle of the Midwest where you can see for miles and miles away. It's awesome to see people on their worst day. The FDA has them shut down. They had, made some choices or brought in some product that allowed, made it so they couldn't run anymore. And you are the solution to their issue. It's also really rewarding to build relationships over time with facilities and customers. Get to know them, their family, the story of their business. I think it is an absolute privilege to be a small part of their brands when you see it on the shelf throughout the country.
Those are absolutely awesome points. I could not agree with you more on everything that you just said. We help protect the world's food supply, and there's a sense of pride that you get from being involved in that, even in a small way. And one of the biggest benefits to this industry, I've been in it 20 years now, and the biggest benefit that I've enjoyed is the job security, especially when, our country goes through tough economic times sometimes, and there's ebb and flow in job security, depending on what you're getting into. But the one area where I have not seen any job security issues is in the pest control industry. There's always opportunities in this industry, and most of them are very well paying opportunities as well. So for people who are looking for an industry to get into that's going to be a long-term career and a very rewarding career, this is definitely one that should be considered.
Yeah. During the pandemic, we worked harder because these facilities were maxed out, and people were home. Consumers were, that 1-800 number on the back of the box. If they found insects in it, they were, the expectation didn't change. The insects didn't know that there was pandemic. Like you said, they don't know that there is hard times. If anything, the consumer spending their hard-earned money on these products, and more awareness, more and more social media exposure it makes us more vulnerable, or makes our customers more vulnerable for a brand damaging event. So our job in the end is to create a program that protects people's brands and commodities.
Absolutely. All right. Well, hey, Pete, that's all I had for you today. I cannot thank you enough for taking some time out of your day to talk to us.
Absolutely. Thank you for the opportunity. It's something that I'm passionate about. It's something that is a necessary part of IPM right now.
I agree. Thanks.
Thank you.
I want to thank Pete for going over some of the basics on how to apply fumigants. Remember, if you stay calm and work the plan, you're much more likely to enjoy a safe and effective fumigation. On the next episode of Dagish America Presents, we'll discuss what you should be doing during the fumigation exposure period, including adding fumigant when needed and monitoring both for efficacy and safety. And remember, if you have a question you'd like for us to answer, feel free to email us at podcast@dagishamerica.com. You can also find us on our website at dagishamerica.com or on all of the main social media outlets. So, until next time, I'm Ben Harrell, and I hope you have a safe and terrific day.